Hey guys, welcome to this video on pointers, arrays and strings. My name is Precious and let's get to it. So in this video we'll be talking about variable scope, strings, arrays, pointers and the difference between arrays and pointers. So before we go into it, let's understand what a variable scope is. A variable scope is a particular region in a program, and the scope determines what program will be able to access a variable and from which region of the program. So basically what this is saying is a scope is a particular section of your code, and that region is what determines what can be accessed or what variable can be accessed and from what region of the program. So there are two types of variable scopes in C programming. The first one is a local variable which is declared inside of a function, and the next one is the global variable which is declared outside of a function. So let's see both of them in action. So here I will create a file called scope, and now we have our file called scope. So let's just create a simple function. So first I'll get the header in, stdio.header. Then our main function, then our return statement. So now we can do everything we want to do inside. Now we have a function called int main. If we declare a function, if we declare a variable inside of this function, it cannot be accessed by another function outside of this. So let's create another function. Let's call this void. Then let's say maybe add numbers. So this is going to take two parameters. Let's call this num1, num2. Then let's add them up. So let's declare a variable called results. So result is going to be the addition of num1 plus num2. Then let's do something with the result. So let's just print out something like result is format specifier for number. Okay. Then new line. And what variable? Variable results. Okay. So we're not returning anything, so it's void. So let's leave it as it is. Then the next thing for us to do is to call this function here. So we can say add numbers. Then let's pass in parameter of 10 and 9. So now that we have this, let's see how these functions behave first, the way it is. Okay. So I'm going to save this. So first I need to correct an error. So the file name was not saved properly. So let's change it to scope.c. Okay, scope.c. So file name has been changed to a proper file name. Now let's run it. So gcc scope.c. Let's send it to a file called scope. Now let's run this and let's see the results. So scope. So it says the result is 9. Okay. Now let's see how it worked. So basically we created a function, okay, with a variable result, and we call the function inside of add number to get the result. Now let's go back into our file. So we are back inside of our file. Now remember what we are trying to explain about the local variable and the global variable. Now what if we do something like this? What if we move this result here, this printf results, okay, and we move it inside of our function here. Okay. All right. Now let's run this. So what we've done now is we've moved this result from the add numbers function into the printf result function. Now let's try to run this. So I'll clear and let's compile. And as you can see, it is telling you now that the result was undeclared, okay? So it's telling you that results is undeclared. First use is in line 11. And this is line 11. But we've actually declared results inside of void. But the main function cannot see the results inside of the void function. That is because this variable is localized to the add numbers function, the variable results. Okay? So a function cannot see the variable inside of another variable. So the only way we can make it accessible is we can use a result or we can make the variable global. So let's use a return statement so that we be able to get out our results. So since we have this now, the only way we can make this function work properly is to return the value of this result, then we can assign it to another variable inside of the main function. So we can return results, then print it out inside of the return statement. All right, so let's do that. So right here, instead of printing it, we can return the sum or return that variable. So we return results, then right here we can now assign the value of the function to another result or something else. Let's say res. Okay, then we can print it out. So result is res. Then also let's change the type. So it's no longer void, now it's an integer. It's returning an integer. So let's compile again. So we have to call this int2. Let's clear the screen. Now let's compile. Okay, compile successful. Now let's run this scope. And as you can see, the result is 9 again. So that is the local variable scope and how to make functions being able to see variables within themselves. Now, what if we want to use a global variable? So let's go back in. For a global variable is it's a variable that you declare outside of the function. So we can initialize our result function here. Okay, now this is now a global variable because it has been created or initialized outside of the functions. That is, both functions will be able to access what is in will be able to access the results variable. So since it is declared outside, we can then come down here and remove the int here because it's no longer needed. Okay, and we can rerun it. Now, because this variable is declared outside, it can be seen by this function, and we can even create another variable. Okay, we can say result2 is equal to 50, and let's use that inside of our printf here too. Okay, so result is and result 2 is okay. So I'm trying to show you now that a variable that is declared outside of the functions can be accessed by both functions, can be accessed from anywhere inside of the program. So save, let's clear, and let's compile. So let's run this, and as you can see, the result is 9 even though it was declared globally, and result is 2 which was also declared. So you see, result 2 is equals to 50, declared globally, but we accessed it inside of the main function, inside of this printf right here. This is it. And also, results was declared globally, but we accessed it inside of the add number function, and we also went in to get the return of the results inside of the main function. So guys, that is it on global. That is it on global and local scope variable. So let's clear our screen and let's proceed to the next one. And now guys, we would be talking about strings, I guess. So yes, strings. So what are strings? A string is a collection of character or characters used to represent data. In C programming, a string is a sequence of characters terminated with a null character. So what this means is, even though you did not add this in your program, C is going to add this at the end of every character that you create. Now, these are variable ways of creating a string. So let's just check them out. So let's say string.c. So the first way to declare a character is to declare a string, is to say something like, so you open it this way, you open this bracket with the name, so we can call this A, is equal to, then you can put in all the characters that you want. Okay, but take note of this, you have to use the double quote. So you can have A, B, C, D, E, F. Then normally you will end it like this, but in the background, C is going to add this for you. Okay, so this means that the character is ending. Though you don't need to add it yourself, but C is going to add it for you. So any string you create, C is going to add this at the back automatically. Okay, same way you can create strings with size. So initially we didn't use size, but now we can use size of 50 and still do the same thing. So it's still the same thing. C is going to add this for you at the back, so I don't need to add it, but I'm just putting it so that you can see it. Also, you can create strings by using individual characters, and like this, so we can say char DC. So without size, so you can say A, C, individual characters, comma, B, C, like that, like that, like that. Okay? Then also, you can decide to do it with, you can also decide to do it with a size. And how do you do that with size? You just go in and add, let's say, 20. All right? But also, there is a last one, and that is the array of strings. So this one works like this. So let's say we want to create arrays of cars. We can say cars, okay, 30, So it's more like creating two arrays. The first one can be null, sorry, empty. Then you have something like your first car could be Mustang, Ford, Volvo. So there is it, guys. 4 ways of creating a string, and also if you want to create an array or string. So let's put this to action quickly. So the first thing first is I'm going to make our function proper. So I'll do something like include stdio.h int main void. So let's just create a simple array called name. And we can print out the results. So name is, so the format specifier for string is an S, okay? The new line, then we can return 0. So let's run this quickly and let's see what we come up with. So let's run it. And as you can see, it says name is Precious. Also, we can take input from the user, okay, using scanf and fgets. I know you know this already, but let's just run through it quickly. So scanf is going to be used to collect input from the user before the first white space. And fgets can take everything from the user. So let's just see it in action quickly. So we'll go back to strings and let's edit that. So the first thing first I will do here is, since we want to take the input from the user, we don't need to give it any value here anymore. So we can say enter your name, okay? Then the first one we use is scanf. So we say scanf, format specifier for string, and we are attaching it to name. Then since we've collected it, we can then go forwards to print it out and say your name is so format specifier for string again, the new line, and name. So it's name we are collecting and we are sending it back. So this is a simple program that will collect the name of the user and print it out. So let's see it in action. So I've just compiled. Now let's run it. So enter your name. My name is Precious, and it says your name is Precious. Let's run it again. So what if I enter my full name, Precious Ireo? As you can see, scanf only printed my first name, but because it met a space, it didn't continue. So for us to be able to print out everything irrespective of white space character, we use this fgets function. So let's convert this to an fget function. So for fgets, we say the name of the array, the size of the array, So size of name, then standard input. That's all. So I can delete everything for scanf. And now, so take notes, f gets the name of the variable, the string variable, then the size of the variable, which is 50, we bring 50 in here, then standard inputs, which means we are taking input from the user. So let's save this, and let's rerun this. So first we'll compile, and let me clear this before I run it. So enter your name. I'm going to enter Precious alone first, and you see it works. Your name is Precious, and let's run it again and do our full name. So Precious, you know what, I will do my complete full name. So you see that there is no respect to white space. It takes everything in. So 3 names already. And as you can see, everything has been printed out on the screen. So that is how to get inputs from the user, or to get string inputs from the user. The next thing we'll talk about now is accessing and changing characters using indexes. So, as you may have known, so let's open our string function again. Our string program. As you can see, we have a character name array, okay? Now what if I go in here and fill in the value? So I use Precious again. Then I can remove, okay, let me take out the fgets. We are not using that anymore. Okay. Now, to access the value of this string array, the array starts from, sorry, double quotes, don't forget that. The array starts from 0, so the P here is 0, 1, 2, 3, 4, 5, 6, 7, okay? Plus that invisible character that will be added for us, this invisible character. This one, though we don't need to add it ourselves, but it's there already from the compiler. It's added already by the compiler. So if I want to access anything in my name right now, all I need to do is to do something like printf So we can change the value of the array by reassigning the value, okay? So let's do this quickly. So I'm going to delete everything we have here. Okay? So let's change some of the characters. Let's change the first one, or the second one, which is 1. Let's change it to capital W. So it's a character, so you use this, single quotes. Let's change the fifth one. I'm just changing it to capital letter characters, and maybe the 7th one to Z. Then let's print the new value. So print f of string name, and let's see what the new value is. So from Precious, let's see what we get. So clear, and let's compile. Oh, there is an error, so let's fix that quickly. The error is from here. So let's compile this and let's run it, okay? And as you can see, it has changed the small letter R to capital W, okay, just like we ask it to do here. So string.c. So you see, we changed the number 1 index to capital W, the number 5 index to capital R, and the number 7 index to capital Z. So that is it on assessing and changing characters using index. So we'll talk about something special now on strings. So let's clear this. So let's talk about string functions. So string functions are actually functions that you can use in manipulating strings. And there's a lot of them in C. We have string lower, convert a string to lowercase. String upper, convert a string to uppercase. String concatenate and string append and concatenate, which appends string 2 to string 1 and characters from string 2 to string 1. Then you also have string copy. You have string sets, so you use it to change strings to another character. You have string reverse, to reverse a string. Then string length, to return the length of a string. String compare, to compare two strings. So let's just see this in action. So let's open up our file again, string.c. So I will delete everything here. And I've already typed the code because it's a lot. I don't want us to do this, so I'm just going to paste. Okay. Oh, sorry. So let's paste what we have. Okay. So our code has been pasted. So I'm going to run us through from the beginning. Okay. So let's go to the top. Okay, so we have two strings here. So the first thing, before you can use your string functions, you have to include the string header. Without the string header, you can't do anything with the string function. Then the first thing we're doing here is we are converting string 1 to lowercase and string 2 to uppercase. So we've done the printf. So let's see. Let's uncomment this out so that we can get our results. So I'm going to put this on a new line. So we are converting string 1 to lowercase and string 2 to uppercase. So let's see it. So compile. So after compiling, let's run. And as you can see, we've been able to convert the first string to lowercase and the other one to uppercase. So let's cut this here and let's see. So this is what I've done here. We had P as capital letter in precious in the declaration, but turning it to string to lower using string 1, you see what we have here. And turning it to upper using string 2, you see what we have here. Okay, so let's proceed. Clear. So clear. Also, you can concatenate strings, and as you can see, this is how it works. So I'm not going to take time to do all this so that we will save time on these videos, but you can see the way the codes are. So to make them work from your end, all you need to do is just to remove the quotes I have in front of them. Okay, you remove the quotes and you get them to work. All right, so that is it, guys, on string functions, so that we don't waste too much time on this. But this is everything. And if you want to do more research, you can actually check online to see how they are being used. But I just want to introduce you to the string functions. So guys, in the next video, we'll talk about something special. Okay, so let's get to it. So guys, the next thing we want to talk about will be arrays. So let's clear our screen. And let's go back to the slide. So arrays, or array, is a collection of similar data or similar type of data, e.g. age of 100 people. Also a data structure that can store many values of the same data type. So let's assume you want to store the names of students. You can use an array. Let's assume you want to store the age of some people. You can use an array because they are all the same data type. They are all integers and they are all age. So let's see how we can create an array. So let's create a document. So let's call this array.c, and let's fill in the important parts. So include standard input header, integer main, then it's void, so we return 0. Now good. So to create an array, assuming we want to create that of the age of users, we would say int age. Remember we did this with string. Okay, so you can put in the size of the array if you want. Naturally I don't like to do that, so I will take that out, but I want you to see that it can be done. So let's fill in some age of some people. And basically that's how you create an array. So this is an array of age of some set of people. And now when you look at array, there is something called the array index. So you don't say 1, 2, 3, 4, 5, 6. No, you say 0, 1, 2, 3, 4, 5. So same thing we did with strings. Yes, you know that we have 6 data here, but you don't start counting from 1, you start counting from 0. That is how you count it. That's how you assess the array index. So you say 0, 1, 2, 3, 4, 5. Okay, so like I said, you don't need to assign the size when you create the array. So I can take this out, which I have done now. Now let's try to assess the values of the arrays. You know, I told you don't start counting from 1, but you start counting from 0. So let's start by saying printf. Okay, so it's an integer and we want to assess the array index of 0. That is the first one. All right, so we can copy this and duplicate it. Let's access 4 of the indexes. So I will change this to 0, 1, 1, 2, and 3. So let's save and let's compile. Array.c output to array. Okay, so that has been compiled. Let's clear, then let's run that. As you can see, 29, 84, 63, and 42 have been printed out. So let's confirm that. Let's do a cut of the program. So if you see at the index of 0 we had 29, and now you see 29 was printed out. So I didn't use a new line character, that's why they are all together. Then at index of 1, age 1, you had 84, and 84 was printed. And the next one we had was 63 at the index of 2. Okay, so we had 63. And at the index of 3, age 3, we had 42. And there you have it, 42 was printed out. So that is how to access the values of an array, okay, using their indexes or their index. So now that we can access values through index, we can also add more values to the array using the index. So let's go back to our program. And right here in our program, so I will delete these printfs, I'll take them out. So right here, we can see that we have some indexes. So we have 0, 1, 2, 3, 4, 5. Now we can add values, more values to the array. So we can do that at, let's say, index 6. Okay, so int age at index what? Index 6. So we are trying to add to the array. We can say make it 50 or 40, or let's say 89. Okay, let's add 2 more. So we can also do int age at 7. Okay, and let's make this 90. So this is us adding to the array. And also we can change the value of an array. So let's change the value of the first array, of the first value. So age 0 is equal to, let's make it 30. And let's change the second index, int age 1. Then let's make that 85. And now, for us to see all the values of the array, what we do is we loop through it. So we are doing 3 things. The first thing we are doing here is we are adding values to the array. So at index 6 and 7, so we have index 0, 1, 2, 3, 4, 5. Then we are adding 2 more values to index 6 and 7. And we are also changing the value of index 0 and 1 from 29 to 30 and 84 to 85. And for you to print out all the values of the array, we use a for loop. So we say for. Okay. So for loop of the integer. Okay. So we are going to loop through the value of the array. So let's use int I is equal to 0. Okay, then I is less than or equal to, so the last array there is 7, so we say 7. Then I plus plus, so let's increment it and let's print out the values. So print f %d and age at each index of I. Okay, so let's use a new line character so that everything is on one line. So again, a repeat of what we've done here. So the first thing we did was to add values to the array. So we are adding values to our array using this. And the second 2 codes, we use that to change the value of the array. So you can change the value of an array by accessing the index. Then the last part is we have decided to print out all the values we have inside of the array so that we can see what is inside of the array currently. So let's run this. So save. Clear. Oh, sorry, we have some errors. Oh, I'm not redefining. So let's go back and fix that. Okay, sorry guys. So out of habits, I was already setting the int again. Since we've declared the array, we are not supposed to use int anymore. Okay, so let's take that out. We've declared it already with the data type at the top, so all we need to do is just to use age. Okay, it's just out of habit. Sometimes you tend to forget yourself, and this is the importance of debugging, so that you can always fix your issues. So that is it exactly. So now I'm adding more values to the array, okay, at index 6 and 7, and I'm changing the values of the array, okay, at index 0 and 1. Then I'm looping through to print out the value of the arrays. Okay, so let's see what we have now. So let me clear this, too much error on the screen. Now that our array has been compiled successfully, let's run it. So that's it. Then I'm going to do, what's it called? I'm going to cut this so that we can see what we have inside. So array.sim. All right, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so you see what has happened. First, the array is 30, but we have 29 here. So why is it 30? Because we changed the value here at index of 0 to 30. Now, at the second part is 85, but we have 84 here. So what happened? Because we changed the value right here to 85. That is why it is printing 85 here. So you see this is how to change the value of an array. Now, if we proceed, we have 63, we have 42, we have 57, and we have 62. We have 62. Then, at the index of 6, we added 89, and you can see 89 has been printed on the screen. So why is our 90 not being printed? Let's see why. So 0, 1, 2, 3, 4, 5, 6, 7. It's correct. Our 9 is supposed to be printed out. But the point is, I've just added more values to this array. So basically, guys, this is it. This is how you add values to the arrays, change value of the array, and also this is how you print out the values of the array. So in the next one, we'll be talking about the multi-dimensional array. So let's clear our screen and let's go into the multi-dimensional array. So a multi-dimensional array is an array that contains an array. Okay, so that is an array that has another array inside of it. So let's see it in action. So we will use our then I is less than 2. So we are dealing with the first array, the outer one. Then I plus plus. So now we can now create the internal array, the internal loop. So let's call this j is equal to 0 and j is less than 3, j plus plus. Close this, and now we can print out the value. So we say print f %d. Then what are we printing out? The values of the array. Okay, so we have I and j. So it will go into those indexes and bring out the values. So let's print a new line after everything so that we can see the results properly. So new line. Okay. And let's run this. Let's see what happens with our multi-dimensional array. So let's compile. there is something wrong. I did not close something, so let me close it. This printf, I did not end the statement with a semicolon. Wrong spelling again. So compile, and that is successful. So let's run this. Okay, now let's do a cut of our array so that we can see what has happened. Now let's begin. So you see our array has gone in to print out the values of 1, 2, 3, 4, 5, 6. Okay, now what we did here was we changed the value of this 3 and this 6, and that is why you have 1, 2, 34, 4, 5. So instead of 6 you now have 90. And how did we print out this value? We use the nested for loop to print out the values of a multi-dimensional array. So the first for loop is going to run for the first row, then the nested for loop is going to run for each of the value inside of the array, and it will jump out to the printf, then go back and run for the second row and begin to print out the values, okay, for the second array. So guys, that is it on nested for loop. Sorry, that is it on arrays, multi-dimensional arrays, and how to print out their values. So in the next video we'll be going to pointers. Okay, so pointers are a great section of C programming, and it's been nice for us to learn a lot about it. So see you in pointers. So guys, we want to talk about pointers now. You may have come across it, but basically it's a simple concept that is a bit difficult for people to grasp. So a pointer is a variable-like reference that holds a memory address to another variable or array. And as you would see, some tasks are better performed easily using pointers because it stores the memory address and not the value. So if you want to declare a pointer, you use this one above with the asterisk, and this is how you normally declare your variable. So the asterisk there is the indirection operator that gives you the value at the address. So when you declare a variable, a space and an address will be allocated, and you can use the memory to access the value that is stored at that address. So let's check this out. So let's create a pointer file called pointer, a file called pointer, and let's put in our necessary things. So include stdio.h, it's main, void. So let's return, we're returning 0. Now let's begin. So take notes. Normally when we declare a variable, we can say int age is equal to 50, right? All right. And if we do a printf of this, let's actually do it. So printf, we can say age is %d, new line, so this is going to print age is 50 for us. But also we can get the address, okay? And let's get the address of that. So we say address of age is, okay? So to get address, you use the %p as the format specifier and ampersand age. So ampersand age, the ampersand there is what locates the address for us. And now let's declare a pointer. Remember we said a pointer is like a variable, so we can say int, then we use the asterisk. I like to do ptr age, so I know it's pointer age is equal to the address of age. Okay. Now, when we go ahead and do something like, so printf, okay. So let's print the value of the pointer. So value of, you will realize that the value of the pointer is the same as the address of the variable. Value of ptr age is, then, okay. So because it's still an address, so we use p to print it out. So new line, I want it on a new line, and we say ptr. Now the good thing is, through the pointer we can get the value of the variable. So we can say print f value stored at ptr age is, that is an integer, okay. So we can do a new line, and we use the indirection operator to get this. So ptr age. So let me explain what I've done here. So the first thing first is I declared a simple variable called age, which is an integer with the value of 50. Then the first thing I did was I printed out the value of this variable. But to also tell you that the variable has an address, I also printed out the address of the variable age. Address of variable age, okay. Address of variable age. And then I declared a pointer, and I pointed it to the address of variable age. Then I printed out the value of the pointer. Okay, you will see what it is now. Then I also printed out the value that is stored in this pointer. You will see what it is. So you will know how pointer works now. So let me save this, and let's compile our file. GCC so let's put it in a file called pointer. Okay, so let's fix the problem. Oh, there is no comma there. It's not easy. Most times I get confusions with the syntax without, you know, mixing the commas and stuff like that. So there's supposed to be a comma here. There should be a comma here too. And a comma here, okay, to separate the variable from the value of the printf. Where is the issue now? Oh, so we don't have anything called ptr, so it's ptr age. So the value is the variable name there is ptr age, not ptr, sorry. So let me recompile. Okay, so it has compiled now. Now good. So let me do a cut so that we can walk through together. Now look, from the first variable we printed out this. We said the age is what? Is 50. That is what is stored in the variable, correct? Then we went on to print what is at the address of the variable, okay, at the second line. You see it? Then using the pointer, we were also able to access the value of the address. Okay, this is the address of the pointer. This is what is at that address. And also to tell you that if the pointer knows the address, the pointer can get the value. So we did the value stored at ptr age using the indirection operator, and see, we were able to get the value that was stored at the memory address above, so 50. So you see, if you have a variable, you can get the memory address. then you can store the memory address in a pointer and use the pointer to access the value at any time or in any function. All right, so let's proceed. So also, since we've been able to access what is stored at the pointer, we can actually change the value of the variable. So let's do that quickly. So let's clear. So like I said, since we are able to use the pointer to access what is stored at the variable, we can change the value of age to anything we want. So let's do that quickly. So we can say ptr age, and we can now make it 100. And let's print out the value. So printf, and let's say new value of age is an integer. Okay, so age. Let's compile this. Let's run it. And as you can see, let me do a cut. So everything worked properly the same, but when it got to this line where we reassign the value of age to 100 using the indirection operator, it's now telling you now that the new value of age is 100. So you can see now that we have been able to create a pointer, check the address of a variable, assign it to a pointer, get the value stored at the memory address of the pointer, and also use a pointer to change the value of a variable. So let's proceed, guys. So that is that on pointer. Let's proceed to other concepts. So guys, we've seen pointers. Now let's discuss about something called pointers and arrays. So basically what we've done before was talking about pointers and single variables, but now, you know, like we said, array is a group of variables that have the same data type or do talk about or describe the same thing. We can also decide or see the memory address of these arrays and also even change their value using the pointer. So let's try that. But first, you have to note that the first element of the array always points to the address. That is, array name is the pointer. This is why strings behave like this without using ampersand for the memory address. So let's check it out. Let's check our array again. So vim we have array.c. Yes, we have array.c. So let's use this document. Okay. So I'm going to delete everything we have now because we want to use this to see pointers and array. All right. So I'm just going to make this a simple array. Okay. So this is a single array, not a multi-dimensional array. Now, let's loop through this array using a for loop. So we can get the value of this array by just using size of, so that we don't need to guess how many numbers we have in there. So age, then divide that by size of. So this will give us the range of the array, size of one of the values in the array. So let's use 0. Okay, then I plus plus. If you don't want to do it the way I've done it, you can just count by yourself. So we'll say 0, 1, 2, 3, 4, 5. Okay, so the array should be I less than 0, 1, 2, 3, 4, 5, I less than 5. Okay, so that is just, let's make it simple. So let's print out the values of the arrays and their memory address. Okay, so we'll say format specifier for the numbers D is equals to, then format specifier for memory address, then new line. And what are we printing? We are printing age, I, then also the memory address of each of the indexes, each of the values in the indexes. So we are printing their various memory address too. So that is it. Let's go ahead to run this. So gcc array.c, so it's compiling, compiled successfully, so clear. Then let's run it. Okay, so as you can see, we've been able to print out the values of the array 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Oh, my index is wrong, so it should be less than 6. But we've been able to print out the values. Then we've been able to print out the memory address. So let's do something. So I will go in and edit our file again. So this should be less than 6. Okay. 0, 1, 2, 3, 4, 5. Less than 6. Then I also want you to see something. So I will say printf array is equal to p. So I want you to see that the first array, the array itself is already a pointer. It points to itself already. So we are going to see that in action. Okay. So we say age. So let's save this. Let's clear, let's compile. Let's clear again before we run. So let's run it. Okay, good. Now you can see what has happened. You see, the first array, the address of the first array, of the first index, is the same as the address of the array itself. So you see that the array itself is a pointer. That is why we don't need to use ampersand when we want to get the pointer value of an array. But doing it individually to get the address of each of the indexes inside of the array, then you go in and do the for loop the way I've done it by using the ampersand to check through the different values of each of the elements inside of the array. So we can further make this code even better. So let's clear. And now that we see that we can access the array by just using age, we can do something by just saying +1, and it will print out the entire address for everything. So let's rework our for loop. So I'm going to delete this. Then inside of the for loop, we just go in and we take this out, and we just turn this to age plus I. So it's going to do the same thing like we had previously, and it's going to get us all the values of the addresses by adding 1 to them based on the size of the memory. So let's save and let's compile. I like to clear, then let's run it. And as you can see, it has done exactly the same thing for us. Printed all the values of the arrays at each index, and also it has printed for us the address of each of the array at their different memory address. Also, we can use the pointer to access the values of the elements inside of the array at each index. So previously, what we have been doing here is we are accessing the array using the index. But now we can decide to use the pointer value itself to access what we have at the different index of the array. And we do that by using the indirection operator, open brackets, age plus I. So for every increment, it prints out the value. Okay, so that's a simple change that you need to make. And if we run this now, so save, compile, clear, then run. As you can see, it does exactly the same thing. By using the pointer value, the indirection operator, like this, we've been able to access all the variables, all the values inside of the different index in the array using the indirection operator of the pointer. And also we've been able to print out the address of each element inside of the array using the pointer. Also, like we did in variables, we can change the values of an array using the pointer. Okay, so let's do that. So just before our for loop, I'm going to change the values of the first element. So that will be, we'll use the indirection operator, age, and we assign it to a new value, let's say 20. Then let's change the last one, so 0, 1, 2, 3, 4, 5. So age plus 0, 1, 0, 1, 2, 3, 4, 5 plus 5 is equal to 50. And let's see how that works. So to change the values of an array, you can do that using the indirection operator instead of assigning it like we used to do before. And let's print out and see if our new values have been recorded. So let's compile, clear, and let's run it. And as you can see, our new values have been recorded as the new values of the array because we changed them using the pointer. As you can see, so we changed the value of the first array at 0, and we changed the one that is last at index 5 to 50. So we have 20 and 50, but the addresses are still the same. So guys, that is it on pointers and array. We'll be talking about pointers and functions in the next one. So let's clear this as we keep talking about pointers. So for us to understand pointers and functions and returning pointers and using pointers in a function, let's do an example. So I'm going to open up our pointer file. So for us to understand pointers and function, we have to create something quickly. So let's do point.c and let's put in our header file. So we're going to create a function that adds two numbers, but it's going to be using the pointer values. So include stdio.h. This is for our main function. Let's just do that first. So void return 0. Then let's create our function. So let's call it add numbers. So it's a pointer. Okay, so the first value is also going to be a pointer. So int num1, int pointer num2, and this one we take the sum, int pointer sum. So what are we doing? We are taking the sum of both numbers. Then we can initialize our sum here. Then we can get the results of this addition. So we assign the results to a pointer results. Then we can call our function add numbers, which is going to take the address of A, address of B, and address of sum. So it's going to reassign the values. Then we can use a printf. The result is okay. So we are printing the value of the result, which is going to be the indirection of the result pointer. So let's save and let's compile this. Point.c 0 point. Now let's run it. So point point.exe, and as you can see, the result is 9. So let's do a cat of point.c to understand what has happened. So what has happened here is we created a function using the indirection operator add number. So it's a pointer, and it takes in the pointer values. So it takes in the value at these respective addresses. Then in our main function, we created some variables, 50, 40, and some, and we sent in their address to the function. So when you send the address, the pointer is going to go and look for the values in those addresses, and it's going to use that in calculating the sum. Then when we want to print out our result, we print out our result using the value at the address of the results. So that is basically how to use pointer in a function. So guys, in the next one, we'll be seeing the differences between a pointer and an array. So quickly, let's check the difference between a pointer and an array. So the difference are first, arrays are declared by using type and varname, while pointers are declared using type, then asterisk, then varname. An array is a collection of elements of similar data type, while a pointer stores the address of another variable. So I don't want to take much time, but you can pause the videos and you can just read between the differences between the both of them. So guys, that is it in this video, and I will see you in the next one. Thank you. Take care. Precious out.